one. We'll try to talk about fundamentals of the partial discharge measurement system as per the IEC 60270. There are different ways to measure the partial discharge, some of them in the field and some in the lab. In the lab, it's governed by the IEC 60270. So this presentation will be limited only to talk about the measurement system as per the IEC standard. Before we start, we need to define what is basically a partial discharge. A partial discharge is a localized electrical discharge in the insulation system or in the surface of the insulation system that partially bridge the electrode. So it's not basically a fault. It is something before we have a complete collapse or a complete fault current inside the insulation system. And they come in different formats. So some of those are, for example, like a cavity here inside an insulation system, a three channel, or when we have an electrode close to the insulation system, or could be due to the trembling point as well, or a corona. These are different formats of partial discharge. Corona is a special case of partial discharge where you have the discharge around the electrode system and doesn't involve any insulation system. Now, these partial discharges, I always call them, they like cancer. Okay, so these type of discharge, if we could not or we do not detect them at an early stage, they will grow up gradually, depending on many factors, and eventually they will lead to the complete failure of the system. When we say complete failure, you will have a complete fault here between the high voltage and the ground. So it's not anymore a localized arcing, but it will be a complete fault current. So it is the best interest of the manufacturer utility to detect this at an early stage. Now, when you manufacture the equipment, we measure the partial discharge at the premises of the manufacturer. And when we install them and when they are on the system, then often we go and do some sort of random check and we try to measure the partial discharge in the field. Okay, so as I mentioned earlier, this presentation is only about the measurement system of the partial discharge at the factory. Now, this test for some equipment it is a routine test. For some others, it is a special test. So, what is the circuit that we use to generate or to measure the partial discharge? We have a high voltage supply. Usually, we have high voltage transformer, which is itself should be free from partial discharge. This is a filter to filter any high frequencies from the supply to the sample, but this is optional as per the IEC standard. Then CS is the sample under test. Could be a cable, could be transformer, insulator, or any type of sample that I am interested to see its partial discharge. Then CK is the coupling capacitor that couples the sample under test with the measurement system. The measurement system is basically you have a shunt element ZM, which is connected to the partial discharge recorder. Now, whenever there is a partial discharge that happens here, you will have this as a discharge, a current discharge, okay? And this current discharge will be measured as a voltage drop across ZM, and that will go directly to the recorder to be displayed. Two things I'd like to mention here. The first one, that what exactly we measure? We measure something called the apparent charge, not the actual charge. And this is something very important to understand, that we don't actually measure the actual charge that result from the pulsive current that happened during the discharge process. And why is that? Because these discharges will travel from its origin to the measuring system, and when it does that, there will be like sort of attenuation, distortion, and even the coupling will be different where this partial discharge happened. So you cannot tell what was the actual discharge that happens here, what is its value, what but what you can tell, what apparent to you, what you can see in the measuring system. That's what we actually report. Finally, how we present the partial discharge on the recorder. There are two major types. Either I show the discharges as pulses here on top of the positive and the negative cycle, or I show the positive and the negative cycle as an ellipse. Start from here. So this point corresponding to that point. Okay. So this is the positive cycle, and this is the negative cycle. So this is the positive and the negative cycle. So these two ways of showing the PD pulses as they happen during the application of the AC voltages. Now, their patterns, where they start, where they end, it is important and gives the inspector some clues about the type, maybe the location of the partial discharge. Now, please join me to the lab, and I will show it to you how the partial discharge look like in reality. I showed you the circuit. I showed you how they look like on the recorder. But let's go and see exactly how the PD system look like in the lab.
This is how the partial discharge setup look like. This is the high voltage transformer here, and here is the sample that we will be testing for partial discharge. And then this is the coupling capacitor, and this is ZM, the impedance through which we will measure our partial discharge pulses. Now here, what we'll be doing, we'll stress those insulators, and at the tripling point where we have the conductor, the insulator, and the air, you will have very high electrical stress. So basically, they will generate the partial discharge. So this is the PD detector. This is the ellipse format that you can show here, the partial discharge at the positive, the top one, and the negative cycle, the bottom one. And here is the value of the partial discharge is around 160 picocoulomb, and this is the voltage that we apply for the system. So that is an overview of the partial discharge detection system.